Welcome to the deep dive. Today, get ready for something, well, huge. We're tackling basically the entire story of everything
Mm-hmm.
from the absolute beginning, the Big Bang, all the way up to, the stuff we're dealing with right now.
Yeah, it's quite the ambition, isn't it?
It is. Think of it like the ultimate backstory for us, for the planet, for the whole universe. We've got a ton of great material you send over, so let's jump in.
Absolutely. And the sources really weave this incredible narrative showing how things connect across, well, just vast scales of time. It's about tracing those threads.
Okay, so thread number one, the very, very beginning, the Big Bang. That's about, what, 13.8 billion years ago?
Roughly, yeah. And it's key to remember, it wasn't like a bomb going off in space.
Right, I always picture that wrong.
Most people do. It's more like space itself expanding rapidly from this incredibly hot, dense point, like the fabric of space-time stretching out.
Carrying all the basic stuff with it.
Exactly. And in those first tiny, tiny fractions of a second, it was just unbelievably energetic. As it expanded, it cooled, and the fundamental forces we know, gravity, electromagnetism, the nuclear forces, they started to separate out.
Like they were all one thing before.
Sort of, yeah. They differentiated. And then from that energy, the first fundamental particles popped into existence, quarks and leptons.
The absolute building blocks, like cosmic Lego.
That's a good way to put it. The smallest bits everything else is made from. And in the first few minutes, things were still incredibly hot and dense.
Hot enough for fusion.
Precisely.
Yeah.
Nuclear fusion happened right then, creating the lightest elements, mostly hydrogen and helium. The universe's first ingredients, basically.
Okay, so now we have a universe full of hydrogen and helium expanding outwards. What next? Gravity has to step in, right?
Absolutely. Gravity is the master architect here. Even though the early universe was incredibly uniform, there were tiny, tiny density fluctuations, little spots that were just slightly denser.
And gravity grabbed onto those.
Exactly. Pulled more matter towards them. Slowly, over millions, billions of years, these denser regions collapsed under their own gravity.
Getting hotter and hotter as they collapse.
Right, heating up intensely. These collapsing clouds were the protostars, the nurseries for the first stars.
And when the core got hot and dense enough, boom, star ignition.
Well, not quite boom, but yes. Nuclear fusion ignites again, but this time in a sustained way. Hydrogen fuses into helium, releasing enormous amounts of energy. That's what makes stars shine.
And these first stars, they weren't just lights, were they? They were doing something else.
Oh, absolutely crucial. They were element factories. Inside their cores, they fused hydrogen and helium into heavier stuff. Carbon, oxygen, even iron.
Wow. So they were actually making the ingredients for, well, us and planets.
Exactly. They were like cosmic alchemists. But many of these first stars were huge, way bigger than our sun.
And bigger stars live shorter lives.
Much shorter. They burned through their fuel incredibly fast, and when they died, they often went out in these spectacular supernova explosions.
Cosmic fireworks.
Pretty much. And these explosions weren't just destructive, they were creative. They forged even heavier elements, and, critically, scattered all those elements, the light ones and the heavy ones they'd made, out into space.
Seeding the next generation.
Precisely. Enriching the surrounding gas clouds. So the next stars that formed already had a richer mix of ingredients.
And that leads to planets eventually.
It helps, yeah.
Yeah.
And on a bigger scale, gravity kept working, pulling these enriched clouds, stars, gas, dust, and also dark matter together into galaxies.
Like our Milky Way, which
Yeah.
is just one of billions.
Billions and billions, yeah.
Yeah.
Our Milky Way formed from this ongoing process. And then within our galaxy, about 4.6 billion years ago,
Yeah.
our own solar system started to form.
From one of those enriched clouds.
Exactly. A giant cloud of gas and dust left over from previous stars began to collapse. Most of it went into the center, igniting to become our sun.
And the leftovers.
The remaining stuff formed a disk around the sun. And in that disk, tiny particles started sticking together. Dust, gas, clumping up.
Accretion.
Accretion, yeah. Gradually growing bigger over millions of years, forming planets, moons, asteroids, the whole solar system family.
Including Earth, which started out pretty nasty, didn't it? Molten rock.
Oh, yeah. A fiery ball, constantly getting hit by space debris. Really violent beginnings. But eventually it cooled down, a solid crust formed.
And the atmosphere.
Volcanoes.
Volcanoes were key. They released gases trapped inside, water vapor, carbon dioxide, other stuff. That formed the early atmosphere. And as it cooled more, the water vapor condensed.
Forming the oceans.
Forming the oceans. Which is where things get really interesting, around maybe 4 billion years ago.
The origin of life, abiogenesis. How did that happen? It still feels kind of magic.
It's one of the biggest scientific mysteries, honestly. We don't have the full picture, but the idea is that in those early oceans, maybe near hydrothermal vents, simple chemicals started reacting, forming more complex molecules.
Like amino acids and things.
Yeah, the building blocks. And somehow, some of these molecules gain the ability to copy themselves. Self-replication. Wow. That's the key step, isn't it?
It's a massive step, from non-living chemistry to something that behaves like life, eventually leading to the first simple single-celled organisms, prokaryotes.
And these tiny early life forms, they ended up changing the whole planet, didn't they, with photosynthesis?
Absolutely critical. Some early life evolved photosynthesis, using sunlight to make food from CO2 and water. And the byproduct, oxygen.
Which wasn't really around before.
Very little free oxygen, no. So over billions of years, these tiny organisms pumped oxygen into the atmosphere. It totally transformed the planet.
Paving the way for creatures like us who need oxygen.
Exactly. It made complex air-breathing life possible. A great example of life fundamentally changing its environment.
And while life is evolving, the Earth itself isn't static, is it? The continents are moving around.
Right. Plate tectonics. The Earth's crust is broken into these massive plates that float on the hotter mantle below. They're constantly slowly moving.
Pushing together to make mountains.
Yep, like the Himalayas.
Yeah.
Or pulling apart to form new oceans. It's reshaped the map of the Earth countless times over billions of years. And you also had things like ice ages, periodically cooling things down.
Okay, so life's evolving, the planet's changing. Then we hit about 540 million years ago. The Cambrian explosion. What was that? This sounds dramatic.
It was dramatic. In a relatively short burst of geological time, maybe tens of millions of years, there was this incredible diversification of life.
Like suddenly lots of different kinds of animals appeared.
Pretty much all the major animal groups, the phyla that exist today, appeared in the fossil record around then. We see the first shells, skeletons, complex body plans. It's like evolution suddenly went into overdrive.
Any idea why? Was it the oxygen?
That's likely part of it. More oxygen meant more energy available, maybe changes in ocean chemistry or ecological feedback loops. It's complex. But the result was this amazing burst of biological creativity.
And life didn't stop there. It started moving onto land.
Gradually, yes. First plants, then insects, then eventually vertebrates. Fish evolved backbones.
Our ancestors.
Way back. Then amphibians emerged, kind of living between water and land. And then reptiles, who were really the first vertebrates fully adapted to living on dry land.
Which leads us eventually to the big guys, the dinosaurs.
Ah, yes. The Mesozoic era, the age of dinosaurs, they dominated the land for, what, over 150 million years?
Incredible. From huge plant eaters like sauropods to T-Rex.
Exactly. An amazing diversity of forms, sizes, lifestyles. They were incredibly successful.
Until they weren't. The big extinction.
Sure.
66 million years ago, asteroid.
The evidence for a massive asteroid impact in the Yucatan Peninsula around that time is overwhelming. It caused global devastation, tsunamis, wildfires, a long impact winter blocking out the sun.
Wiped out the dinosaurs. Well, most of them. Birds survived.
Right. Birds are essentially modern dinosaurs. But the big ones, and many other species, were gone. And that cleared the stage.
For mammals, who'd been kind of hiding in the background.
Exactly. Mammals have been around, mostly small, often nocturnal, living in the dinosaur shadow. With the dinosaurs gone, all these ecological niches open up.
So they diversified, filled those gaps.
Rapidly. An explosion of mammal evolution leading to everything from bats to whales to, eventually, primates.
Our branch of the tree.
Our branch. And in Africa, several million years ago, our ancestors started doing something really significant walking upright. Bipedalism.
Why was that so important? It freed up the hands.
That seems to be the key advantage. Hands-free for carrying things, making tools, gesturing. It set us on a different path.
And then brains started getting bigger.
Over a long time, yes. We see a trend towards larger brains in species like Homo habilis, then Homo erectus. Along with that came more sophisticated stone tools, evidence of more complex social groups, maybe controlling fire.
It's a gradual process.
Very gradual. Lots of different hominin species existed, sometimes overlapping, until finally, around 300,000 years ago, our species, Homo sapiens, emerged, also in Africa.
And what made us different? Language?
Complex language seems to be a huge factor. The ability to share detailed information, plan collectively, build complex cultures, abstract thought to art, symbolism, thinking beyond the immediate here and now.
And that combination allowed us to spread out.
It seems so. Homo sapiens began migrating out of Africa, maybe starting around 100,000 years ago, or even earlier. They proved incredibly adaptable, moving into almost every environment on Earth.
And they met other kinds of humans out there, like Neanderthals.
Yes, Neanderthals in Europe and Asia, Denisovans in Asia. There was interaction, sometimes competition, and we know there was some interbreeding. Too many people today have a small percentage of Neanderthal or Denisovan DNA.
But eventually, only Homo sapiens remain.
That's right. Why exactly the others went extinct is still debated. Climate change, competition, maybe disease, likely a combination of factors.
Okay, so humans are spread across the globe, living as hunter-gatherers. Then comes another massive change, agriculture, around 10,000 years ago.
Yeah, the Neolithic Revolution, starting in places like the Fertile Crescent in the Middle East. People started domesticating plants and animals, farming.
And that changed everything, didn't it? People settled down.
Fundamentally. Instead of moving around constantly, people could stay in one place, build permanent villages. Food became more predictable, though maybe less varied initially.
And populations grew.
Dramatically. Agriculture could support far more people in a given area, and with surplus food, not everyone had to farm.
So you get specialization. Potters, weavers, priests, rulers.
Exactly, specialization of labor. And with that, social hierarchies start to develop. Some people accumulate more wealth or power than others. Villages grow into towns and eventually cities.
The first civilizations, Mesopotamia, Egypt, the Indus Valley, China, growing up in fertile river valleys.
Right, places where agriculture was especially productive. And these early civilizations developed incredible things, writing systems.
Like cuneiform and hieroglyphs.
Yeah. Monumental architecture, pyramids, ziggurats, organized religion, complex irrigation systems, early forms of law and government.
And these civilizations expanded, forming the first empires, like the Akkadians or Babylonians.
Yes, you start seeing larger political units emerge, often through conquest. Empires rise, they flourish, innovate, build amazing things, influence their neighbors. And then often they decline or fall, replaced by others. It's a cycle.
A pattern we see again and again.
Throughout history. Think of the Persians, the Greeks, especially Athens, with democracy and philosophy.
Socrates, Plato, Aristotle.
Right. Then the Romans, massive empire, huge influence on law and engineering. Chinese dynasties rising and falling, inventing paper, gunpowder. Civilizations in the Americas, the Maya, the Aztec, incredible astronomers and mathematicians.
Yeah.
The Inca in South America, masters of infrastructure.
It's just an incredible tapestry of human achievement and, well, conflict, too.
Absolutely. And weaving through all this are powerful ideas, philosophical systems trying to understand the world, religious beliefs offering meaning and moral codes.
Like Buddhism spreading from India, Confucianism in China, Greek philosophy influencing Rome, the Abrahamic faiths, Judaism, Christianity, Islam spreading across vast regions.
These ideas shaped cultures, motivated people, sometimes united them, sometimes sadly divided them. They're a huge part of the story.
Okay, zooming ahead again. Around the 15th century, Europeans start sailing much further. The age of exploration.
A major turning point. Suddenly you have sustained contact between continents that were largely separate before Europe, the Americas, Africa, Asia.
Leading to massive exchanges?
The Columbian Exchange.
Exactly. Goods, plants, animals, technologies moving back and forth, but also diseases, which devastated populations, especially in the Americas. And crucially, it led to European colonization on a global scale.
Creating new power dynamics and inequalities that lasted for centuries.
Definitely. A really complex and often brutal period that reshaped the world.
And around the same time, intellectually, things were shifting too. The scientific revolution.
Yeah, 16th, 17th centuries, people like Copernicus saying the Earth goes around the sun, which got Galileo in trouble.
Indeed, and Newton figuring out gravity and the laws of motion. It was a fundamental shift towards observation, experimentation, mathematical reasoning to understand the natural world. Less reliance on ancient authority or the religious dogma.
And that spirit of reason influenced the next century, didn't it? The Enlightenment.
Directly. The Enlightenment, mostly 18th century, applied that rational thinking to human society, politics, morality. Ideas about individual rights, liberty, democracy, separation of powers.
Influencing revolutions in America and France.
Hugely influential. Challenging the power of absolute monarchs in the church, advocating for reason and human rights, still shapes our political ideals today.
Then comes another massive transformation, maybe starting late 18th century in Britain. The Industrial Revolution.
Another game changer. New technologies, steam engine, power loom, factories, mass production.
People moving from farms to cities for factory work.
Huge urbanization, yeah. Created incredible wealth for some, new products, faster transport, but also terrible working conditions for many, pollution, new social classes, new economic systems like capitalism really taking hold.
And new challenges and ideologies, like socialism, emerging in response.
Right. It reshaped society completely, led to Britain's global dominance for a time, and then spread to other parts of Europe, North America, Japan.
And that sets the stage for the 20th century, which just feels intense. 2 world wars.
Unbelievably destructive, fueled by nationalism, imperialism, competing ideologies.
Yeah.
Millions killed, changed the map of the world.
Plus the rise of totalitarian regimes, fascism, communism, the Holocaust.
Some of the darkest chapters in human history, but the 20th century also saw incredible progress.
Right. Science, technology, medicine leaping forward, antibiotics, flight, computers, nuclear energy.
Which also brought the threat of nuclear war during the Cold War.
True. It was also a century of struggles for rights, civil rights, women's rights, decolonization as empires broke up.
Yeah, a period of immense upheaval, terrible violence, but also significant progress and liberation movements, just packed with contradictions.
Which brings us more or less to now, the digital age, the modern hustle. Everything feels so connected, so fast.
It's another profound shift, isn't it? The internet, mobile tech, social media, it's changed how we communicate, work, get information, everything. Unprecedented connectivity.
But that connectivity brings its own problems, like misinformation. It feels like it's everywhere.
It's a huge challenge. Information, both true and false, spreads incredibly quickly online. It's often hard to tell what's reliable.
And algorithms can feed us more of what we already believe, creating echo chambers.
Exactly. They can filter our reality. Plus, there's deliberate disinformation, people intentionally spreading lies for political or financial gain. It has real-world consequences for public health, for democracy.
It makes you question the basic myths we might have about, information just being neutral or easily accessible, and wonder what lies are being targeted at us. Critical thinking feels more important than ever.
Absolutely essential, and understanding our own biases that make us susceptible.
Another big issue the sources point to is economic inequality. Even with all this technology and globalization, the gap between rich and poor seems huge.
It's a persistent problem, and in many places, it's widening. If you trace it back, the roots are deep colonialism, the way industrialization happened, specific economic policies.
It challenges that simple idea of pure meritocracy, doesn't it? That everyone succeeds just based on hard work.
It does. While individual effort matters, of course, we have to ask if that narrative hides the systemic factors where you're born: access to education, healthcare, historical disadvantages. Are there convenient lies obscuring these structural issues? Or myths that justify extreme wealth concentration?
Yeah, and connected to that maybe is social division. It feels like societies are becoming more polarized.
We're seeing that in many places, yeah. Divisions along political lines, cultural identities, ethnicity, socioeconomic status, people retreating into their own groups.
And social media can make that worse by amplifying conflict.
It seems to play a role, creating those echo chambers we mentioned, sometimes rewarding inflammatory rhetoric. But historical grievances and cultural differences are also major factors. It really highlights the need for empathy, for trying to understand different perspectives.
And maybe questioning some of the myths we tell ourselves about our own group or nation being superior, or the lies used to demonize others.
Precisely. Because these narratives, these myths and lies, can be incredibly powerful drivers of division and conflict.
It feels like these 3 things, misinformation, inequality, division, are all tangled up together.
They absolutely are. They feed off each other. Misinformation can worsen division and justify inequality. Inequality can fuel resentment and make people more vulnerable to misinformation that blames scapegoats. Division makes it harder to cooperate on solving any problem, including inequality.
So tackling them requires seeing those connections.
Definitely. It demands critical thinking, looking for evidence-based policies, and ultimately, a real commitment to social justice, to equity, to finding common ground.
Wow. So we went from literal cosmic dust right after the Big Bang, through stars being born, life emerging, dinosaurs, empires, revolutions, all the way to these really complex societal problems we're facing right now.
It's quite a journey. Seeing that vast sweep of history, the chain of cause and effect, hopefully gives some perspective on why things are the way they are now.
And maybe helps us be a bit more aware of the myths and potential lies that shape our understanding so we can work towards something better.
That's the hope, isn't it? Striving for a more informed, a more just future by understanding the forces that brought us here.
Well, thank you for joining us on this epic exploration. Seriously, it covered a lot. We hope this deep dive gave you, our listener, a richer sense of how interconnected everything is, from the dawn of time to today's headlines.
We really do. And maybe think about how your own actions, your own beliefs, fit into this immense ongoing story, how echoes of the past influence the present, and how we all contribute to what comes next.
Yeah, that's a great thought. We'd love to know what other huge topics or historical periods you'd like us to tackle in a future deep dive. Let us know.
Please do.
And if you found this valuable, maybe a bit mind-expanding, we'd be so grateful if you'd subscribe and share it with someone else who might appreciate it. Your support really helps us keep doing these kinds of ambitious explorations.
Absolutely. So until next time, keep thinking about those connections. From the smallest particles to the largest structures, and how understanding them helps us navigate our world.